the joint, that's the jam. Turn that up, play it again. That's the joint, that's the jam. Turn that up, play it again. That's the
Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard.
Here is a problem set up for our example. So we have a person standing on icy surface with the skates on, and a ball is thrown at him at certain velocity VB. And in the first part of the question, the person catches the ball, and we would like to know the velocity of the person holding the ball when the ball is caught. And in the second part, he doesn't catch the ball, but instead the ball bounces off the chest at the velocity of 8 meters per second. And what is the velocity of the person in that case? And we have some parameters here, masses of the both objects and the velocity of the ball to begin with, 10 meters per second. Let's define our positive x-axis this way, and hence we can say the following from the conservation of momentum. So momentum in the beginning, it's just the momentum of the ball. So that's to the left, so we have a negative mass of the ball times the velocity of the ball. And after the ball has been caught, they both move with the same velocity. And so the total mass is m of the ball and the mass of the person times some common velocity v. And from here we can solve for v. That's minus mb divided by m plus mb times the velocity of the ball. And mass of the ball is 0.4 kg. Total mass of the two is 70.4 kg. Initial velocity 10 meters per second. And for this one we get about 6 centimeters per second, and that is negative. And this means that the ball and the person move to the left, which of course makes sense. What about when the ball hits the chest and bounces off? Well, the initial momentum is the same, just that of the ball to the left, hence the minus. And after the impact, the person is moving at some velocity, of course, just general mv. And the momentum of the ball is to the right because it bounces off. So it's going to be mass of the ball times VB2, which we know is 8 meters per second. And we again solve for V. So we get, first of all, mv equals mb times, well, there's a minus sign there, so we have VB, and then this one comes from the other side, so VB2. And then we can get the expression for V itself, so it's going to be minus MB over M, and VB plus VB2, like this. So mass of the ball 0.4 kg, mass of the person is 70 kg, magnitude of the initial velocity, that's 10 meters per second, and then we have the final velocity of the ball, or the speed, 8 meters per second. And let's not forget the minus signs to start with, so, and the magnitude is 0.1 meters per second, so that's 10 centimeters, or minus 10 centimeters per second. And the minus sign meaning, again, the velocity of the person is to the left, but the interesting thing is here is the magnitude is larger, so it's 10 centimeters versus 6 centimeters per second in the first case. And this is because in the second case, the ball bounces off the person, so the velocity of the ball changes by 18 meters per second as opposed to 10 meters per second in the part A. And because the momentum of the ball changes more, that means that the momentum of the person must change more as well, and hence the larger magnitude.